here the following. So this is an example problem here, and we're going to look at, it says find f of p, so we're putting p inside of f first. So what you should have done is you should have written f down with a blank plus 1, and then put p, which is negative x inside, and then call this f of p of x. Make sure you label it and put a box around it, okay? Next, you want to find f of p of 2. You just plug a 2 in. In this case, it's kind of weird because you have a negative under the square root. If you left it like this, this would be acceptable, or you could call this I square root of 2 plus 1. Both are correct here, okay? Next, you want to find the domain, or here, this might throw you off. It says let h of x equal f of p of x. Basically, h of x is just what f of p of x is, i.e. it's what you have here. So you have this function, and now you have to find the domain. So you have a couple of options here. You can either first graph this out if you want to and then find the domain from there, or you can follow the domain rules here. So this is our domain sheet here, and if you look at it, we have a radical. So we're going to look at the domain under radical and square root, and we're going to read the rule. It says set all terms in the square root greater than or equal to 0. So this is my square root here. But that's the term underneath it. I'm going to set it greater than or equal to 0. I'm going to solve this. And I divide by negative, which means the inequality sign switches. I graph this out. So it goes from 0, and it's less than, because the arrow is pointing that way. So interval notation is going to be an arrow means infinity, and because it's left is negative infinity to 0, and it's bracket because it is a closed dot, and this is my domain. So later on we're gonna see, folks, that our picture is gonna coincide with the domain here. And lastly, it says following part B describe the shift, stretch, compression, reflection, parent function of h of x. And h of x is the same function that we've been working with here. Because it's plus 1, it's shifted up 1 unit. And then the negative means that it's a reflection, and because it's negative on the inside, it's reflected over the y-axis here. Now this is where you need to kind of put all your skills together. So we're going to graph this now, okay? And the reason I had you write these characteristics is so you can graph them. So all you do, and you don't have to do this, if you want to do this in your head, that's cool. I like to draw my parent function first. And my parent function is the square root, right? And the square root kind of looks like the punch. I'm going to draw that out first. Here's my original. And what am I doing to my original? First, I'm going to reflect it over the y. This is my y-axis here. This means this is my mirror. So if I flip it over, it's going to look like this here. Okay? And then I need to shift it up 1. So if I do that, it doesn't start at 0 on the y, it starts at 1. And now I go ahead and do the following, and it looks like this. So on your exam, you can put the little dots here. I would recommend doing this with pencil and then erasing those, okay? And this is how you would graph it. And we've got this entire thing, which is going to model what you need to do for your test, okay?